Hello, this is Hart Hagen in Louisville, Kentucky. I am a climate reporter. I've done 400 episodes almost of an audio podcast here on local radio, Forward Radio, and I have about 240 some videos on my YouTube channel. I would like to share with you what I'm thinking today about climate, and especially we're talking about, I thought I had the anyway, I'm blanking on the title. The title is Are Water Cycles Are Water Cycles the Missing Piece of the Climate Puzzle? So what I want to do first is share with you something that some basics of water cycles. See, I believe that water cycles are a more important, more momentous aspect of climate change than CO2 is. And maybe they're co-equal. Maybe CO2 is a big thing, and maybe water cycles are also a big thing. I tend to think that water cycles and ecosystems are even more important. In my view, we have a living planet because we have a livable planet because we have a living planet. Life creates the conditions for life. If it were not for the ecosystems that we have, the biology that we have on this planet, then the planet would be very hot or very cold. But we have a temperate, livable, habitable climate because we have living ecosystems. Living ecosystems tend to be intelligent and self-organizing. They tend to create the circumstances in which they can thrive. To me, this is a much more significant aspect of our climate than merely whether or not there are greenhouse gases. So let's talk about part of that. I'm going to get to an article from a news site called Euronews. And the title of that article is Are Water Cycles an Important Part of Missing Piece of the Climate Puzzle? But first, I wanted to lay the groundwork by talking about one particular ecosystem, which is a forest, and talk about how that forest tends to regulate the climate in a way that makes the climate habitable for us, habitable for wildlife, habitable for other species of plants, and for fungi. So let's look at that. What I have listed here are the first four things are here's what a forest does in order to regulate its environment and in fact cause rainfall. The items 5 through 12 are what a forest becomes in order to make rain and regulate rainfall. The idea being that rain and precipitation are a very important part of our climate. It is unusual and unfortunate that in recent years we have started to talk about climate only in terms of temperature, but a very important part of our climate is water and water cycles and precipitation. You can't speak intelligently or think clearly about climate unless you also talk about how frequently is it raining, how much rain do we get annually on average, how long of a period of time is it in between the rain events, so that that's just how you describe climate. So anyway, I'm going to run through these 12 things that a forest does or becomes as it relates to water, so we can have an appreciation of the important role that forests and other ecosystems play in regulating our rainfall, bringing rainfall, making rainfall happen. Number one, evaporation. A forest causes evaporation because there's so much water coming out of the leaves of the trees. The water goes in through the roots, up through the trunk, out through the leaves and it evaporates. According to the U.S. Forest Service, it evaporates at about a regular tree will evaporate about 11,000 gallons of water per year. If you divide that up, it's about 50 gallons per day during the growing season. So one regular sized tree, one regular full-grown tree is evaporating about 50 gallons per day during the growing season. Item number 2, condensation. Trees and plants, and especially mature forests, cause condensation to occur. That's because whenever water is coming from the leaves of the tree, it's also emitting condensation nuclei. Condensation nuclei are things like bacteria, or also maybe volatile organic compounds that cause the water to be able to condense. This causes condensation. Number 3, cloud formation. When you have condensation, then you have the possibility of cloud formation. And of course, clouds are very important for rainfall. Number 4, precipitation. The forest makes precipitation possible because it's much easier for a raindrop to fall into a cool, moist environment. The forest creates a cool, moist environment. And as opposed to a hot, dry environment, you're going to have a hot, dry environment if you have desert sand, if you have bare dirt of a crop field, if you have pavement, if you have concrete. All of those things create a hot, dry environment that's harder for a raindrop to fall into. But a forest creates a cool, moist environment that makes it easier for the raindrop to fall. Number 5, a forest becomes a sponge. Now, as compared to what? We've got 2 things here. So same list. This is the place where a forest has been cut down. This is a place where a forest still exists. Compare this with this. This is not much of a sponge. This is more of a sponge. The leaves on the trees provide a sponge. The rain rains, and the water clings to the leaves of the tree. The water also clings to the organic layer on the floor of the forest that includes fallen leaves. It includes dead trees. The sponge also includes the soil beneath the ground, because the soil beneath the ground is healthy soil, because there's nothing better for soil than the roots of the trees, plus the fungi. Healthy soil is a living ecosystem, and there's nothing better than plants to jumpstart that ecosystem. So you're starting to get the idea. A forest is very important for different aspects of the water cycle. Number 6, the forest is a heat bank, which means as the surrounding air is warming up, the forest is slower to warm up. As it's cooling down, the forest is slower to cool down, because the forest has water in it. Trees are rich with water. The organic matter in the forest has water in it. As opposed to this is not going to have much moisture in it, because it doesn't have trees. It doesn't have leaves on the trees. It doesn't have much organic matter on the ground. And the soil in this picture is going to be degrading because the plant matter is no longer there. I'm going to try to run through the rest of these pretty quick. This forest becomes a cooler. In this picture, where the forest has been cleared, it's no longer a cooler. It's more of a hot place. Number 8, the forest is a humidifier, because you have all this evaporation coming from the leaves of the trees. The humidifier keeps the forest moist, and especially it keeps the soil from drying out. Number 9, the forest is an umbrella. Number 10, the forest is a windbreak. Number 11, the forest is an air pump. And number 12, the forest is a habitat. So number 11, the air pump, that is called the biotic pump. The biotic pump is a theory about what creates winds and what creates rains. The biotic pump says that forests actually create their own rain. That's why you can be very close to the ocean. Some deserts are very close to the ocean. Look at a map of Africa. Look at the Sahara Desert. It's a desert even up close to the ocean. But in the Congo rainforest in Africa, that is far from the ocean. Same with South America. On the west and on the east of South America, it can be relatively dry, but in the middle, you have the Amazon rainforest, because forests create their own rain, and that is largely because of a relatively new theory from my friend Anastasia Makareva and her colleagues, Viktor Gorshkov and others. Mian had a role to play in developing the same theory, which says that plants create their own, plants create weather. So let's click out of this and go to something else. And I'm going to see if it gives me, I have to click a couple of things. I'm going to have to click present, and I'm going to go to, I'm going to stop that screen, then I'm going to click present again, and I'm going to share screen. And the screen I'm going to share this time is the article entitled, Are Water Cycles, let me make sure I have the right screen here and make sure I'm in the right screen. Yes. So are water cycles the missing piece of the climate crisis? Click out of this just a minute. So what we've done so far, I went through 12 things that a forest does or a forest becomes as it interacts with water cycles, so as to demonstrate that forests and grasslands and other ecosystems, a very similar thing is true for wetlands, grasslands, even regenerative farms can be an ecosystem that creates the climate around it. So what we're going to do is look at an article that's like, yes, somebody is talking about this. It's not just a few of us at Eco Restoration Alliance and Biodiversity for a Livable Climate. It's some, mainstream media talking about what is the talking about the significance of water cycles. And let me make sure we are in the right place. So this is a site called Euronews.green, and it says, are water cycles the missing piece of the climate crisis puzzle? My short answer to that is yes. Water cycles are the missing piece of the climate crisis puzzle. Let's talk for a minute about how missing water cycles are from the climate crisis puzzle. The climate conversation today is all about carbon. It's all about carbon dioxide. It is the main story we're being told in relation to climate is that first we had a habitable climate. For the last 10,000 years, we've had a habitable climate, and that is going to pot now because we've been burning too much fossil fuels, which has created carbon dioxide. Too much carbon dioxide in the atmosphere. Carbon dioxide is a greenhouse gas. This greenhouse gas is warming the atmosphere too much, and as a result, we have all this flooding, drought, wildfires, and heat waves, which in turn causes mass migration. It causes low agricultural yields. It causes people to starve, etc. I think that is a brutally oversimplified story. It is a story that does violence to the facts on the ground. And the missing piece of the climate puzzle, in my view, is that water cycles make our Earth habitable. We have a livable planet because we have a living planet. If it were not for the living systems, if it were not for the biology of our planet, then the planet would be very hot or very cold and maybe both, maybe swinging between extremes. I don't know, but it would not be a well-regulated, moderate environment. We've been losing that regulatory capacity in recent years because for the last 5,000 years, we have taken away the ecosystems of the earth. According to Canadian scientist Vaclav Smil, we have reduced the biomass, or the total quantity of living matter. We have reduced the biomass on Earth by about 50% in the last 5,000 years. We've done that by deforestation. When you deforest, you're reducing the biomass. We've done that through the wrong kind of agriculture because we've destroyed the soils. When we destroy the soils, when we degrade the soil, then there's less living matter within the soil. We saw also overfished the oceans. We've poisoned the oceans. We've acidified the oceans. The oceans are too warm, but mainly through overfishing. We have we've eliminated 90% of the large fish in the oceans. We've eliminated 85% of the whales in the oceans. In so doing, we have reduced the total biomass on Earth. We have reduced the total quantity of living systems, the total quantity of living matter on Earth in the last 5,000 years. And that's only accelerating over the course of time. What that has done is it has thrown our water cycles out of whack such that we don't have this regulatory, this capacity of our living systems to cause precipitation, to soak up the rain, etc., and the things that they do. So let's get into this article. It says, are water cycles the missing piece of the climate crisis puzzle? The answer is yes. Let me go down here to a paragraph. Let's see if this, okay, I wanted you to see this. Climate models are based largely on extrapolating fossil fuel emissions, but is a missing critical factor linked to plants and water making things worse. So it's all fossil fuels all the time. And the powers that be, the climate gurus, are pretending that we're going to somehow get the climate back into line by reducing fossil fuels. And reducing fossil fuels would be a great thing, but not for the reasons we're told. And we're also pretending that anybody has a plan for actually reducing fossil fuels. Solar and wind are not going to reduce fossil fuels because for a couple of different reasons. Let me talk about this just a minute. So solar power and wind power are not going to reduce fossil fuels substantially for two reasons. One is they require a lot of fossil fuels to make. The other reason they're not going to reduce fossil fuels is that our economy is growing year by year by year. Our economy is growing exponentially. An exponentially growing economy, it means you have exponentially growing consumption of energy. So the economy is growing faster than solar and wind can catch up with. Not least of all, let's assume for the sake of discussion that solar and wind do independently produce a substantial amount of energy, then is that going to displace fossil fuels? History teaches us that when you introduce a new source of energy, it does not reduce the consumption of the old sources of energy. So that's just something to think about. Let's go back to the article. So when we talk about, I was going to go down here to an article, to a paragraph that starts with a big tree. Let's see if I can find it. Water cycles. Okay, here we go. No plants, no rain. That's a key thing. So we're talking about an alternative view of what can fix climate change. And the alternative view is like increase the amount of plant matter on the surface of the earth. Plants grow every year, but we cut them down faster than they can grow. We want to bring plants back. We want to stop all the deforestation. We want to have cover crops on agricultural fields. We want to treat our oceans right so that we have enough phytoplankton in the oceans. There's lots that we can do to bring back plants. Bringing back plants is the quickest way to restore our climate because, for one thing, plants have a cooling effect all of their own. And for another thing, plants tame our wild water cycles. Plants bring rain. Going on down, here we go. A big tree can cycle a lot of water. So we're going to prove that plants make rain, that trees make rain, and especially mature forests make rain. It says a big tree can cycle a lot of water this way, as much as 100 liters a day. This way, what way are they talking about? Plants suck up water from the soil and sweat it out through their leaves as they photosynthesize. This is called transpiration. A related concept is evapotranspiration. And so it says down here, in a big tree can cycle a lot of water in this way, as much as 100 liters per day. That's about 25 gallons in English, in the backward measurement system that we have in the US, that all plants contribute. They also release microscopic particles that seed the rain. So plants cycle a lot of water, they release the microscopic particles that seed the rain. Going on down, how water affects global temperatures is complex. It takes energy as heat to turn water into vapor. As plants transpire, it cools the surrounding air at ground level. In the air, the vapor works to block infrared radiation coming off the Earth's surface, keeping heat in and warming everything up. But when it reaches higher in the atmosphere and condenses, it releases heat again. As the air is thinner, it's much easier for heat to get out into space, and the overall effect becomes cooling again. So what it's saying right here is that once the water gets up to the cloud layer, when it condenses, it throws off a certain amount of infrared heat. Heat radiates back out into space. It's radiation energy as opposed to convection. So it's like, the sun is 93 million miles away. That energy is not getting here by way of convection. It's getting here by way of radiation. So radiation is, light, visible light is part of the electromagnetic spectrum. On one side, you have visible light, and then on one end you have ultraviolet, and on the other end you have infrared. These are both invisible parts of the electromagnetic spectrum. And so what they're talking about here is that when water condenses, then infrared heat, we're putting heat back out into space. Wouldn't it be great if we would put some of this heat back out into space? There's only about a 1% excess of incoming heat over outgoing heat. So if we just put a little bit more heat back out into space, then that would solve the greenhouse effect. We're not talking about that very much because we're only looking at one aspect of the greenhouse effect. The only aspect of the greenhouse effect we're looking at is greenhouse gases. The greenhouse effect has other parts of it. If you have a hot surface, then that's part of the greenhouse effect. plants tend to create a cool surface. But if you have a hot surface like pavement or bare dirt or desert sand, that helps create the greenhouse effect. It simply means that there's more heat coming in than there is going out. We can fix that by having fewer hot surfaces and more cool surfaces, or we could fix that by having more heat going out by, fixing our water cycles. And the way we fix most of our water cycles is with plants and trees, and especially mature forests. Okay, it says alongside pollution, worsening weather, CO2 emissions, and biodiversity collapse, another main feature of the Anthropocene is the destruction of vegetation for agriculture, creating progressive desertification. The Anthropocene is a word for that, the new era that we're in. Some people think it ought to be called something else, but Anthropocene means the epoch or the era of the earth that is most characterized by the effect of humans. But more to the point, we have multiple ways that we are, it's the destruction of vegetation is the main point here. So it says here, this is known as the biotic pump. Vegetation literally takes heat from the ground and pumps it out into space. I'm going to wrap up with this. The biotic pump is the theory pioneered by my friend Anastasia Makareva and her late colleague Viktor Gorshkov. It was also another kind of the similar observations were made by a recently deceased climate scientist from Spain by the name of Millán. But the biotic pump is where vegetation literally takes heat from the ground and pumps it out into space. So I think I'm going to leave it about there, except I'm going to go back up here and we're going to talk about what gets measured gets done. Okay, here we go. So only what we measure can be counted. However, the most meaningful impacts may not be easily measurable. So he's making a point, this author is making a point, and I'm going to make a counterpoint. I mean, it's an excellent point. We can only count what we measure. But the question is, why are we not measuring the effects of our water cycles and the effects that plants have in jump-starting water cycles? Why are we not measuring this? What we normally hear is that we're not measuring it because it's too complicated. These small water cycles are too local. Water cycles can be very tiny. Water cycles can operate on a square foot. You can have a water cycle on a square foot. Certainly a square mile, you can have its own little water cycle going on. So, which is much harder to measure than carbon dioxide, and much harder to quantify it. So the story goes. But I think it's like anything else. You can make some assumptions. We can make some assumptions about, here's a place that has plant matter and here's a place that doesn't. How much cooling effect does that plant matter have on that square acre, on that square mile? We can make some solid assumptions about that based on satellite data. If you look at a map and it's mainly green, then you can surmise that there is more water cycling going on in the green part of the map than this brown part of the map over here. At that level, it really wouldn't be hard to measure and quantify the effects of our water cycles and the effects of vegetation on climate. I'm going to click out of this. I've got a couple minutes left. I want to give you something to think about. And that is trying to get good climate information today is like trying to take a drink of water from a fire hose. You know the fire hose, there's lots of water coming out. Try getting up close to a fire hose and getting a drink of water from that fire hose. It's hard to do because so that water coming from the fire hose is analogous to the amount of climate information that's coming to us. And that would be okay if the information coming to us exhibited some critical thinking skills. That would be okay if the amount of information about climate coming to us was reasonably accurate. It would be okay if the amount of climate information coming to us was not grossly oversimplified, but the climate information that comes to us from the United Nations, from the New York Times, from the Washington Post, from TV news, it's grossly oversimplified, and a lot of it is stuck in this false dichotomy that says, do you believe in climate change or do you not believe in climate change? Well, that's just purposely divisive nonsense that comes to us from political parties and from a class of people who want to keep us divided. It's just simply useless. So that's the state of the climate conversation today. That's the status of today's conversation related to climate. What we could do is we could be talking about how and where we can restore the plant matter to the surface of the earth such that it tends to restore our water cycles. It tends to lower temperatures. It tends to bring more regular precipitation. We could be doing that, but we're not doing that. And the reason is that there's a class of people who exist to keep us in the dark. Let me end with this quote from one Henry Adams. So Henry Adams lived from 1840 to 1920. He was a child of the establishment. He was the great grandson of John Adams, the second president of the United States. He was the grandson of John Quincy Adams, the fifth or sixth president of the United States. He was the son of Charles Francis Adams, who was the ambassador to the United Kingdom in the Abraham Lincoln administration. So he comes from a very distinguished family. Henry Adams himself was a historian who wrote a 7 or 9 volume history of the Jefferson and Madison administrations, 16 years in the early part of the 16 years that spanned the administrations of the third and fourth presidents of the United States. Adams' history was praised for its literary style and its command of the documentary evidence. So Henry Adams was no lightweight, and he was no flower child. He was a child of the establishment. Henry Adams said the following. He said, the press, we would call it the media today, the press is the instrument, darn it, I usually get this quote just right. The press is the product of a moneyed system. Here it is. The press is the hired agent of a moneyed system and set up for no other purpose than to tell lies where their interests are involved. One can trust nobody and nothing. Let me repeat that quote. The press is the hired agent of a moneyed system and set up for no other purpose than to tell lies where their interests are involved. The purpose of the media, especially the corporate media, they're good independent journalists, but the purpose of the media is to tell lies on behalf of the moneyed system. If Henry Adams is to be believed, I think Henry Adams is a good source for that. I don't think the media, I don't think the purpose of the media is to tell you the truth. The purpose of the news, of the media, is to throw you off the trail, is to obscure what is really happening in the world. News is not news, it's propaganda. History is propaganda. History is mythology. The history that we learn in school is mythology. So, you can believe me or not believe me. I'm telling you that's where I'm coming from. That's what makes sense to me. So when it comes to climate information, which is something I've studied for 5 years, when it comes to climate related information, I submit to you, I humbly submit to you that the information that comes to us about climate change is not supposed to tell you the truth. It's supposed to tell you a false narrative that is far from the truth. And it's supposed to keep citizens at odds with each other. It's supposed to keep neighbor hating neighbor. And it's supposed to keep us hating our fellow Americans or our fellow citizens of the world. The purpose of it is not to tell you the truth. So I leave you with that. And thanks. I'm here to cheer you up. But anyway, thanks for joining me. Have a great day.